Modernage MCQs Physics second year, unit number 15, AC circuit, part 3. When an inductor is connected to AC source, the current lags the voltage by option A 120 degree, option B 90 degree, option C 60 degree, option D 30 degree. The key is 90 degree. Therefore, the correct option is B. Reason: when an AC source is connected to an inductor, the magnetic flux changes with AC current. I is equal to Im sin omega t. It induces EMF. V is equal to L delta I over delta t, or V is equal to L into delta Im sin omega t divided by delta t, which is equal to L Im omega cos omega t, because delta sine omega t divided by delta t is equal to omega cos omega t, which can be written as Vm sine omega t plus pi by 2, because L omega is equal to XL. Therefore, L Im omega is equal to Im XL, which is equal to Vm. Hence, current lags the voltage by pi by 2, which is equal to 90 degree. What is the power dissipation in AC capacitive circuit? Option A 0, option B IMVM, option C IRMS, or option D I square RMS, or the key is 0. Therefore, correct option is A. Reason: the power dissipation is P average is equal to IB average is equal to Im cos omega t into Vm sin omega t average, or average power is equal to IMVM into cos omega t into sin omega t average, which is equal to IMVM cos omega t average into 0 is equal to 0, because average of sin omega t is 0. Hence, power dissipation in a capacitive circuit is 0. The power dissipation in pure AC inductive circuit is found to be option A 0, option B IMVM, option C IRMS, or option D I square RMS, or the key is 0. Therefore, the correct option is A. Reason: the power dissipation is P average is equal to IB average is equal to Im cos omega t into Vm sin omega t average, or P average is equal to Im Vm into cos omega t average into sin omega t average is equal to Im Vm cos omega t into 0, which is equal to 0. Hence, power dissipation in an inductive circuit is 0. An AC source allowed 10 milliampere current to 5 kilo ohms to deliver a power of option A 50 milliwatts, option B 100 milliwatt, option C 500 milliwatt, option D 750 milliwatt. The key is 500 milliwatt. Therefore, the correct option is C. Reason: the power delivered to a resistor is P is equal to I square R, which is equal to 10 into 10 power minus 3 whole square into 5 into 10 power 3, or P is equal to 500 into 10 power minus 3 watt, which is equal to 500 milliwatt. Hence, the AC source delivered power of 500 milliwatt. The ratio of frequency of AC to DC is Option A 0, option B 50, option C 60, option D infinity. The key is infinity. Therefore, the correct option is D. Reason: the frequency of AC is either 50 Hz or 60 Hz and the frequency of DC is 0 Hz. Therefore, the ratio is frequency of AC divided by frequency of DC, which is equal to 50 or 60 divided by 0, which is equal to infinity. Hence, the ratio is infinity. The SI unit of reactance is option A ohm, option B farad, option C coulomb, option D ampere. The key is ohm. Therefore, the correct option is A. Reason: the reactance of an AC circuit is X is equal to V divided by I, which is equal to volt per ampere, which is called ohm. Hence, the SI unit of reactance is ohm. The inductive reactance is option A pi FL, option B FL, option C pi omega L, option D omega L. The key is omega L. Therefore, the correct option is D. Reason: the EMF across an inductor is V is equal to Vm sine omega t plus pi by 2, where Vm is equal to omega L Im R. Vm divided by Im is equal to XL, which is equal to omega L. Hence, inductive reactance XL is omega L. The capacitive reactance is option A pi Fc, option B 1 by Fc, option C pi omega C, option D 1 by omega C. The key is 1 divided by omega C. Therefore, the correct option is D. Reason: the current through a capacitor is I is equal to Im sine omega t plus pi by 2, where Im is equal to omega C Vm R. Vm divided by Im, which is equal to Xc, which is equal to 1 by omega C. Hence, the inductive reactance Xc is 1 by omega C.